Okay, so welcome. So on the extension aspect of these series, what we're going to do is we're going to create a recursive formula. And what recursive means is that you are going to use the previous term to generate the next term. So when you see the word recursive, it's a function that uses the previous term to generate the next term. So for example, if I'm looking at this example right here, I've got a value that says, look, I've got 5 times a to the n minus 1. A to the n minus 1 means the previous term. So if I'm going to generate a term, what I'm going to do here is the first term is 6. So now if I'm going to find the second term here, the rule says 5 times the previous term. So you can see that I just set up all of these values, right? 5 times the previous term, 5 times the previous term, 5. Okay. And what I'm going to do is just substitute in. So if I take 5 times the previous term, I would take 5 times 6. So 5 times 6 would be 30. Now, if I want to find the third term, what I would do is I would take 5 times 30 this time, which would give me 150. And if I wanted to find the fourth term, what I would do is take 5 times 150 this time. So 5 times 150, because it's the third term. So if I do 5 times 150, I'm going to end up with 750. And then I've got 5 times 750. I use a previous term to generate. And then I've got 5 times 750 is going to be 3,750. And then if I want to find the sixth term, which is what I'm looking for the sixth term, I would take 5 times 3,750. And what's nice in your calculator right here, I got 18,750. What's nice in your calculator right here with recursive formulas is you could just hit times 5 times 5 times 5 times 5. Okay? So for example here, if I'm doing 5 times 6 we started with, right? I get that. If I just hit times 5, you can see that the same thing is just going to come up. It's going to generate the sequence. So recursive formulas are kind of easy for calculators and computers to compute because you're just using the previous term to generate the next term. Okay? All right, next example that I wanted to kind of show you right here is how do we write a recursive formula when we're given a series, right? So you want to start with, well, first of all, is this an arithmetic or geometric series, okay? Or a sequence, sorry, and you could do -5 here, -5 here, -5. So what happens is we're subtracting 5 every time. So we know that the common difference here is going to be -5, okay? So now, what's nice about these sequences or series is you always start with the first term. A1 is 14. And the next is, well, how do we get to a rule? What's the rule? Well, the rule says I'm going to take a to the n minus 1, and that means the previous term. For example, if I'm looking for like the ninth term, I need to take the 9 minus 1, which is actually the eighth term, and then subtract 5, right? Because I'm subtracting 5 every time. So that's what I'd write. This would be my recursive formula. I would take the previous term and then subtract 5. So a thing to think about is a to the sub n minus 1 means the previous term. Okay? So now you can also do the same thing with a geometric sequence. Okay, so right here you can take a look at this and understand that each time we're multiplying by -2. Multiplying by -2, multiplying by -2. So here the common ratio is -2, right? But it's the same idea. I start with the first term, okay? So my first term is going to be 2, so I've got my first term is 2. And what am I doing every time? Okay, I'm doing every time I'm taking the previous term, a to the sub n minus 1, and then what am I doing? I am multiplying by the common difference. So we identify the common ratio here, which is -2. So I'm multiplying by -2 every time. And you can see that this is a recursive formula. So a recursive formula has the first term, sometimes also has the second term, and then how to get to the future terms. Okay? Now, out of these, which recursive sequence would produce the sequence 2 to 1 to 3? Okay? And you're going to see here, right, there's a formula here that's not quite as simple, right? Because from 2 to 1, you're going down 1, and then from 1 to 3, you're going up 2, right? So we're going to have to kind of generate this sequence using our rules here. So let's look at the first one. So the first one says 5 times the previous term minus 2. The second one says -2 times the previous term plus 5. The third one is the opposite of the previous term plus 3. And the third one is 3 times the previous term minus 1. Okay? Now to start off with, if you notice, all of these have the first term as 2. So all of them work. So let's see if we get 1 as our answer. So I take 5 times the previous term, which is 2. Previous term, previous term, previous term. Okay, so which ones generate the number 1? Okay, so right away, 5 times 2 is 10, minus 2 is 8. That does not work. -2 times +2 is -4 plus 5 is 1. That works. The opposite of 2 is -2 plus 3 is also 1. That works. And 3 times 2 is 6, minus 1 is 5. That does not work. So 2 of them definitely do not work. Okay? So now we need to determine which one of these work in between the next two. Okay, so the rule is I take -2 times the previous term plus 5. Here, it's the opposite of the previous term plus 5, or plus 3, sorry, plus 3. Okay, so now what is the previous term? In both of these cases, it's 1, right? That's the second term is 1. So let's check. -2 times 1 is -2 plus 5 is 3. That works. And this one, we're going to get -1 plus 3 is 2. So very clearly that does not work. And then that is going to be the recursive sequence, or the formula for the recursive sequence that you're given. Okay? Now working on to some different sort of notation, which is similar to Euler's notation you can see in some of these examples. All right? But what we're looking at here is f of 1 is 7. That literally means that if we're looking at a number here, and then we've got f of a number, which means the sequence. Okay, so the first term is 7. What's the second term, third term, fourth term, so on and so forth. Okay? All right, so what we want to do here is find the value of f of 5. So if you look at it, if I substitute in the number 2 to find the second term, so I substituted in right there, 2 minus 1 means f of 1. Which literally means we're taking 5 times f of 1, which is the first term. Okay, so this is another way to represent a sequence. So if I'm looking here, if I'm trying to generate, well, f of 2, I'm going to take 5 times f of 1, which is the first term. Right? So if I substitute 7 in here, I'm going to get 35. So what are you doing every time? You literally are just multiplying by 5. So if I wanted to continue, I would say f of 3 is 5 times f of 2. What is f of 2? You figured it out that f of 2 is going to be 35. So again, you're just multiplying by 5 each time. So 35 times 5 is 175. And then f of 4, and then f of 5, because we're looking for f of 5, right? So then I just take 5 times f of 3. Now we know f of 3 is 175, right? So if I just multiply by 5, I'm going to get 875. And then 5 times 875 gives us the final solution of 4,375. So this notation is just the first term is 7, the second term is 35, the third term is 175, the fifth term or fourth term is 875, and we're looking for the fifth term, which is 4375. Okay? Hope this helps.